Hey everyone, Kyle Walker here. If you love cars, fixing things, or just want to understand your vehicle better, you're in the right place. I share hands-on tips, smart driving advice, and straight-up car talk without the fluff. Make sure to hit that like button, subscribe to the channel, and stick around till the end. You don't want to miss what's coming up. Let's get into
Engineers
it.
rightly call the braking system of a car the main component of any vehicle. The task of this device is to ensure safety while driving. Having a brake at his disposal, the driver can slow down in time or stop the car completely. Additional systems actively help when driving and during parking. If you examine the mechanical components only, you will not see anything complicated in the braking system. It consists mainly of a drive and actuators. This principle of the device is applied to all brakes. But modern cars have gone much further. Manufacturers began to use auxiliary systems, with the help of which it was possible to increase the efficiency of the brakes. Types. First, we need to familiarize ourselves with the types of braking systems that are used on vehicles. Brakes have been used since the first cars were built. Back then, the design was extremely simple and primitive. But even it was enough to provide effective braking because of the low maximum speed. But gradually, cars got faster. This forced manufacturers to develop more effective and complex braking mechanisms. If we talk about varieties, the classification of braking systems for cars provides several different solutions depending on purpose, drive, working mechanisms. Since a number of elements and aggregates are involved in braking, it is necessary to understand how the systems differ from each other. Purpose. Let's start with the purpose and types of brake systems. Passenger cars provide for the use of service and parking brakes. In the role of additional devices are backup and mountain braking systems. The working type of the braking system of passenger cars slows down the movement of transport and allows you to come to a complete stop. The peculiarity is that the intensity of speed reduction directly depends on how much the driver presses the corresponding pedal. The name of the parking brake speaks for itself. With its help, the car blocks any possible movement while parked. The wheels are immobilized and therefore excludes arbitrary movement, which can occur when the vehicle is on some slope. Backup or emergency brakes serve as an auxiliary mechanism in case the main unit breaks down. Most passenger cars do not have a backup emergency brake, and instead this role is delegated to the parking system. Mountain brakes are relevant to apply in the design of trucks. Such a system allows you to forcibly reduce engine speed when the truck is moving downhill. This slows down the movement of the truck without using the main working brake. This is a useful solution, as it eliminates overheating and prevents possible failure of the main system. Drive braking systems are also distinguished depending on what type of drive is used on each of them. The purpose of the actuator is to transmit the force of the working mechanisms or to perform certain actions on the components of the system responsible for braking. The drive can be mechanical, hydraulic, pneumatic, combined. In mechanical systems, the working parts are actuated by means of rods, levers, and special cables. In conventional brakes, this actuator is hardly ever used. However, it is often used as part of the parking brake. Hydraulic actuators are the most common in the creation of passenger cars. The basis of its operation is the physical property of the liquid, which is its incompressibility. With its help, the force is quite easily transmitted to the working mechanisms, and therefore the driver does not have to press hard on the pedal. The pneumatic actuator is widely used in the design of commercial vehicles. The working medium is compressed air, which is pumped through a compressor. When the driver presses the pedal, special channels open. Through them, the air goes into the chambers directly connected with the working brake mechanisms. Combined drive is relevant for special equipment. The peculiarity of the system is the simultaneous use of different drives. It is not installed on passenger cars. Service mechanisms. The working mechanism is needed to have an effect on the car wheels, slowing down the speed of their rotation. Therefore, they are the main components of the entire system. They are divided into belt, disc, and drum. Tape mechanisms are practically not used. The only exception is special equipment. The essence is that a drum with a belt is installed on the axle, designed to transfer rotation to the wheels. When the driver brakes, the belt is stretched, and due to the friction force, the speed of rotation of the drum decreases. Disc mechanisms have proven to be the most common among passenger vehicles. The main element is a disc, which is rigidly fixed on the wheel hub. The actuator has a direct connection to the caliper standing on the brake disc. Here there are friction-type pads. When the pedal is pressed, the pad presses against the disc, and the frictional force contributes to deceleration. If the system is drum, then the disc is replaced by a drum mounted on the hub. Inside the drum there is a pair of pads, which are shaped like a crescent. They are mounted on the fixed part of the hub. When braking occurs, this wire unclamps the pads, after which they start pressing against the drum, thereby slowing down the speed of its rotation. Read also, is it possible to use the gear instead of the handbrake, and how to do it correctly? Advantages and disadvantages. Since there is no point in talking about tape drives, it is worth discussing the strengths and weaknesses of disc and drum brake systems. To the advantages of disc solutions include the following points: high level of efficiency, low weight compact dimensions, low temperature of hydraulic fluid during operation, high reliability, stability. At the same time, disc brakes are not well protected from dirt, which can negatively affect the performance of the entire system. As for the drum analogs, their advantages are high force values. This allows the drums to be used effectively on large cars and trucks, as their mass is impressive, and therefore it is more difficult to stop such vehicles with disc brakes. Long service life. Dirt does not penetrate inside the drive, and therefore the linings wear with less intensity. Affordable price. This applies to the purchase and maintenance. But not everything is so perfect with drum brakes. Do not forget about the slow speed of the reaction to the pedal pressure, as well as the likelihood of sticking brake pads. This happens if the car is left on the street with the handbrake on in extreme heat or excessive cold. Safety systems. Modern cars are equipped with additional equipment that is designed to improve safety and raise the efficiency of the main braking mechanisms. Many people know what an anti-lock braking system is and why it is needed. It was first learned about it in practice in 1978 when the Bosch company developed a novelty and put it into production. ABS braking system is designed to prevent the car wheels from locking when the driver sharply presses the pedal and brakes. This allows the car to remain stable even in the event of an emergency stop. Plus, ABS helps in maintaining the vehicle's handling. But modern trends and increasing speeds have forced manufacturers to come up with new solutions to ensure proper safety. In addition to ABS, which has already become a standard solution on all cars, several new systems have been added, namely brake assist, dynamic brake control, cornering brake control, electronic brake force distribution. All these auxiliary but very useful additional braking systems are called BA, BS, or EBS, DBC, CBC, and EBD for short. BA in order to increase efficiency. After the introduction of ABS, EBS braking systems were introduced. On some cars it is simply called BA or BS. The name does not change the essence. The system is aimed at reducing the time required to operate the braking system. ABS maximizes braking efficiency when the brake pedal is fully depressed, but it does not activate when the pedal is lightly depressed. The booster activates in certain situations and provides emergency braking if the driver applies the pedal sharply but fails to apply enough force. The system measures how quickly and with how much force the pedal is pressed. If necessary, the pressure inside the braking system is automatically and instantly increased to maximum values. To realize this idea, a speed sensor, which monitors the movement of the rod, and an electromagnetic type of drive were built into the pneumatic amplifiers. When a signal is received from the sensor about a very fast movement of the rod, i.e., the driver sharply presses the pedal, the electromagnet turns on and increases the magnitude of the force acting on the rod. This is what reduces the braking time, sometimes saving the driver's life. Modern EBS systems are able to remember the features of the driver's brakes in normal mode, thereby recognizing emergency braking. The presence of EBS is possible only if ABS is present on the car, as they closely interact with each other. In short, EBS is used to apply the brake pedal, which activates the ABS system. However, EBS is not able to distribute forces to the different wheels. Now there is an active development of an improved version of this braking system, which allows to work together with cruise control, automatically recognize obstacles ahead, and help to reduce the braking distance. Specialists from Bosch are confident that the novelty will be even more effective than the standard brake assist. Read also, Audi cars, localization of assembly plants and production features DBC. The authors of this braking system are engineers from the German company BMW. In some ways, the solution resembles the previously discussed BA. But the German system helps to accelerate and additionally strengthen the pressure increase in the brake actuator of the car during an emergency stop. Even if the driver applies a small amount of force, the braking distance is reduced to a minimum. The automatic system reads the rate of pressure increase and the force applied by the driver. This is how the computer determines whether the situation is dangerous. If so, the pressure is immediately increased to the maximum, which allows the car to brake faster. In addition, the control unit reads the speed and brake or data. DBC is based on the principle of hydraulic boost, unlike competitors, where the vacuum principle is applied. Practice shows that hydraulics contributes to better and more accurately distributed braking force during emergency and emergency stops of vehicles. The DBC electronics are directly linked to the stabilization system and ABS. CBC. This system was also developed by Bavarian specialists from BMW back in 1997. When the car starts braking, the rear wheels on the car are unloaded. If this braking occurs in a corner, the rear axle may skid as the load on the front part increases. CBC is closely related to ABS. They work together to prevent the rear axle from skidding when the driver starts braking on corner entry. The system optimally distributes the braking forces. As a result, skidding does not occur even if the driver applies the brake pedal firmly and sharply. The signals from the ABS sensors are transmitted to the CBC. The speed at which the wheels rotate is also determined. This data allows the braking force increase for each of the cylinders to be adjusted. This is done in such a way that the increase is more intense on the outer front wheel when viewed relative to the turn. This principle of operation helps to prevent skidding. In cars, the system works all the time, but it remains invisible to drivers. Although the benefits of such a solution are enormous. EBD. There is a lot of talk about EBD brake force distribution system, but not everyone understands exactly what it is. EBD stands for Electronic Brake Force Distribution System. From this, it already becomes roughly clear what functions and tasks the system performs. In cars, this solution is used to redistribute the forces from the brakes between the rear and front wheels. Plus, the brake force distribution system, or simply EBD, helps in competent automatic redirection between the left and right side of the vehicle based on the current driving conditions. EBD is part of the traditional ABS system, which is electronically controlled. When the car moves straight and starts braking, the load is redistributed. Namely, the front wheels are loaded and the rear wheels are unloaded. If the rear brakes have the same amount of force as the front, the likelihood of rear wheel lockup will increase significantly. Using special speed sensors, the ABS electronic control unit determines the right moment and adjusts the force. To a large extent, the correct distribution depends on the weight of the load being transported and how it is positioned. The EBD is also useful when braking during corner entry. This increases the load on the outer wheels in relation to the corner and relieves the load on the inner wheels. This ensures protection against possible blockage. The EBD is guided by signals from sensors mounted on the wheels, as well as deceleration or acceleration sensors. This allows the system to determine which conditions need to be created for safe braking. By combining different valves, the working fluid pressure is redistributed. As a result, each wheel has a different pressure reading. Modern brakes have retained their original principle of operation, but new developments have managed to significantly increase their efficiency. Now the car is not just able to brake. It does it accurately, avoiding wheel locks, skids, and other troubles that can arise when you need to urgently reduce speed. Many people underestimate the importance of modern braking systems. Although they help to feel confidently on the roads, enter corners at high speeds, and timely stop in front of the obstacle that jumped out in front. Presence of all brake system assists is gradually becoming a mandatory condition in the production and sale of new cars. And it is absolutely right decision, aimed at improving safety on the roads and reducing the number of accidents or traffic accidents. In conclusion, modern braking systems have evolved significantly, offering enhanced safety and performance for vehicles. From traditional disc and drum brakes to advanced technologies like anti-lock braking systems, electronic stability control, and regenerative braking, each system plays a crucial role in ensuring a smooth and secure driving experience. As automotive technology continues to advance, we can expect even more innovative braking solutions that prioritize both safety and efficiency. Understanding these systems not only helps drivers make informed choices, but also highlights the importance of regular maintenance to keep our vehicles performing at their best. Thank you for watching, and stay safe on the road.